Hi everyone, and welcome to another open source meetup. I'm Claire Cox. I'm one of the organisers of the meetup, and we were hoping to be live streaming from London, but due to the current COVID situation, we made the decision, along with the London community, to run this as a virtual event instead. So all being well, fingers crossed, we'll be live streaming from Bristol for the next event, and that will be in early March. So if you're in the Bristol area and you're interested in presenting at that event, do get in touch with me or one of my fellow organisers through the Meetup channel. As always, I want to start by thanking the technology consultancy Scott Logic and the Open Source Foundation FINOS for their continued support of this meetup. We've got a jam-packed event for you today. We've got 3 great talks coming your way. We'll have time for questions at the end of each presentation. So do get your questions into the question box and we'll take as many as we can. So without further ado, let me hand you over to your first speakers. So let me introduce you to Hilary Carter, Vice President of Research at the Linux Foundation, and Colin Eberhardt, CTO at Scott Logic. And they're going to talk to us about the state of open source in financial services. So over to you.
Thanks very much, Claire. Hello, everyone. I'm Hilary Carter, VP of Research at the Linux Foundation. I happen to be based in Toronto, Canada, and it's a real pleasure for me to share the screen with my partner in this research project, one of them, Colin Eberhardt, and to collaborate with Scott Logic once again. They're really terrific partners and leaders in the open source community. So really thrilled to have this opportunity. And today we're going to kick off with describing a research project that we pursued at Linux Foundation Research in collaboration with FINOS, our technology partner in fintech and open source. And so I'll begin just with a little bit of background about Linux Foundation Research, our program, and then dig into the research project specifically. So about LF Research, I was brought into the Linux Foundation earlier this year to launch this new business division. And the idea, the vision by Jim Zemlin and the leadership team at the Linux Foundation was essentially this. What if we could create the definitive repository of insights and data into open source and provide decision useful deliverables for the entire ecosystem, a set of materials and a public utility that would allow further insight into what's happening in open source in general, and to dispel myths and misperceptions about what open source is, what it isn't, what the opportunities are, what the challenges are, all for the purpose of informing community-wide strategy, whether that strategy was around resourcing or staffing or any other kind of decision that an organization might take, how it might approach the public sector, how it might consider its transformation plans and its use of open source. So that's the objective of LF Research, create decision useful materials and create new value for everyone in the open source community. And really what we want to do is look at open source through the context of the world's challenges today, to update the research that was done in open innovation right around the year 2000 through till, I'd say, as late as 2013 by the academic community, which took a long look at open innovation. What was the rationale behind it? Focused a lot on Linux, focused on Mozilla, Wikipedia, and other types of open innovation. And then there really wasn't a lot of updating of that body of knowledge. And here we are today in a scenario where we have a pandemic that persists. We have climate change that's bearing down in all parts of the world. And we have the acceleration of technology that's changing what it means to be a technology company or a company that's deeply committed to innovation. So that's the why and wherefore of Linux Foundation Research. And here is how we're going about our work. We're conducting research essentially in 3 different buckets, different areas. The first area is our industry vertical. Now, it's in this vertical that we conducted our research project with FINOS, because FINOS is a focus area, which is in financial services and fintechs. So that was one of our very first research projects that we kicked off and published in 2021. But there are more projects to come along industry vertical lines, and there's really no shortage of opportunity to describe what's taking place. I think the rationale for Linux Foundation research is the reality that new industries are collaborating in open source today. We're seeing agriculture, the agriculture industry, join the Linux Foundation and donate code for open collaboration and to strengthen resources. We've seen the film and entertainment industry join Linux Foundation a number of years ago. The Academy Software Foundation, the same academy that hands out Oscars every March. All the film studios have come together under Linux Foundation to solve common problems and to create shared value by sharing technology development and technology cooperation, whether it's in software, in hardware, or in standards. So we have this Cambrian-like explosion of what's going on here. We also conduct research along technology horizontal lines. So you can see the list, there's no shortage of technologies. We're also looking at the convergence of those technologies. What happens when we have blockchain interacting with AI or with the IoT? How is Linux impacting the IoT and embedded spaces? What are the challenges unique to different kinds of technology convergences? And finally, we've kicked off a number of research projects at the ecosystem-wide level for those topics that don't neatly fit into industry vertical or technology horizontal. And I'll give you some examples. Next week, we are publishing a research project on the state of diversity, equity, and inclusion in open source, identifying the challenges as well as the opportunities to create more inviting, more inclusive community cultures across open source projects. So that's about LF research. And now I'll dig into a little bit about our financial services project that we did with FINOS. It's the 2021 State of Open Source in Financial Services. So we kicked off the project in the late spring, and it truly was a group effort. I like to say that research is a team sport, and there was no better example of team collaboration than this project. And it really set the standard of what is possible through research to engage our communities and to create shared value beyond creating shared code or shared standards. We create shared knowledge through working together. And so in this project, we worked with, of course, Scott Logic, the team at LF Research, but we also worked with FINOS, our commissioning project at Linux Foundation, as well as GitHub and Wipro. And it was wonderful to come together as a community of like minds with shared interest in creating a meaningful data set that we could all use, that would add value to all of us in our different endeavors, and really to create a baseline study, something that had not been done before, about the financial services sector and the role of open source within it. How active is this industry? What are the barriers? What are the opportunities? What are the challenges? It was really, we had lofty goals to create a baseline of understanding against which we could compare year over year. So we set about the business to come up with a project plan, vision, and scope of what we wanted from this research project. What was the data that would be most useful? And we were committed to conducting both a quantitative survey as well as conducting qualitative research and engaging with more than a dozen interviewees, subject matter experts from across the ecosystem at the intersection of financial services and fintechs in open source. And through that qualitative process, we were able to come up with some really rich insights, things that you just can't find online, and to learn from individuals about what it is that they see going on in this sector. So I'll tell you now a little bit about our methodology and fielding of the survey itself. We launched the survey in June. We leveraged the might of the Linux Foundation blog and our newsletter subscriber community to announce this project and to encourage those at the intersection of either working in the financial services sector or providing services to it. We wanted qualified respondents who really knew what was happening, what were the technologies at play in the financial services sector, either from the vendor perspective or end user perspective. We posted the survey link in our newsletter. Our project communities, FINOS, ScottLogic, also shared the survey across their communities and through their marketing efforts. And we found that that getting qualified sample in this space is at times a bit of a challenge. And interestingly, in 2021, the methodology that is most effective for generating insights in a survey is by way of an email ask. Email is still the best way of engaging communities in getting survey responses, especially when those emails are personalized. We did do a direct email campaign to trainees who had certified in Hyperledger Fabric and other Hyperledger technologies, wanting to have those qualified respondents who understood at least one element of open source and financial services. And we did a final last call for survey respondents in July. So we really made a terrific effort. If any of you took the survey who are part of this meetup today, really want to say thank you for your time and talents. And I hope that if you do see surveys from the Linux Foundation or from FINOS or our project partners, that you'll gladly give 10 or 15 minutes of your time. In terms of our deliverables, we present a deck of our survey findings. And this is just one slide of what you can expect to see on demographic information about our financial services respondents. Our final sample was 208, which was a minimum solid threshold. If we can expand our sample next year, all the better. But making sure that we had the right insights when we did our final analysis was really quite important, the right sample. And we did eliminate a number of respondents from the survey based on level of complete and other factors. The report itself is another deliverable that really is the magnum opus of the research project, because it combines the findings from the survey with the qualitative interviews that were conducted. And we created the report along the following thematic lines, which were also reflective of the questions and the themes that were created as part of the survey. We describe the state of governance, leadership issues, consumption of open source, the motivations behind open source contribution, consumption, culture, aspirations, and of course, demographic data. And I would say it's a terrific read, and I'm very, very pleased with the finished product, the collaboration that went into creating the actual report document itself. It is available under Creative Commons license. Feel free to share it. Feel free to post it on your websites. Spread the word about what's happening in open source and financial services. And the report is your tool. We hope you use it. We hope you derive valuable insight from it. Another tool that we create as part of our research deliverables are infographics, which each of these tiles, if you will, are they represent key findings and takeaways from the research project. And they serve a dual purpose. One is to help convey the findings of the report in a more visual fashion to disseminate the information broadly to help attract attention to the report itself, and to just have something that's a little visually inspiring. These tiles can be repurposed. They can be embedded right in the slide of a presentation deck, or they serve as very effective social media shareables. So you might see them continuing, to circulate online as a means to drive audiences to the research findings themselves. So feel free to share. Sharing is caring. Finally, we're committed to sharing open data. And the survey results of the FINOS State of Open Source and Financial Services survey is available on data.world, the Linux Foundation's FINOS dataset, under CDLA Permissive 2.0 license. And this is an opportunity for those analysts who want to get creative with data, perhaps want to dig in and do some of their own analysis. So we completely encourage that by providing open data. And if there's anything that you uncover in your review of this data set that we've missed, that's an opportunity for conversation. And I'm really pleased that Colin, who you'll be hearing from in a minute, has done exactly this. Passionately committed to analytics and insights. Colin has taken a deep dive in the survey findings and has done some comparative work with other research projects in the community. So I'm really pleased now to hand over the talk to Colin, who will dig into our research findings more specifically and some of the other analytical work that he has independently pursued at Scott Logic. Thank you, Colin.
Thanks, Hilary. Yeah, that was great. Okay, as Hilary mentioned, the survey is relatively extensive. I think the report is 40 or 50 pages, and it touches on a wide range of topics and issues relating to open source. Rather than try to cover everything, I'm just going to follow a single thread through the findings and try to tell a little bit of a story supported by the data within the report. So the story I'm going to tell you is about bridging the contribution gap, specifically within financial services. So Hilary, if you move on to the next slide, please. So I'm starting from a position that hopefully you will all agree with, that open source is everywhere. Now, the use of open source within enterprise is hard to measure. There are numerous reports. This one is from the Synopsys 2021 report that just shows a relatively explosive growth in the number of open source components. I know Open UK also publish a total value of open source within the UK. It's very big numbers. I'm assuming that everyone is with me that open source is pretty much everywhere. So if you move on to the next slide, Hilary. What I want to talk about in a little bit more detail is most organizations have clear consumption policies, but what do these consumption policies mean for the people on the ground? Does it mean we're confident in consuming? Does it mean we're empowered? Does it mean we're encouraged to consume? Now, the report that the survey that we did in collaboration with Linux Foundation and FINOS was specifically looking at financial services. Now, within financial services, there is an additional burden of responsibility, whether it's responsibility relating to regulatory compliance or risk within your own organization. Generally speaking, developers feel an extra burden, and that's something that I want to explore. So Hilary, if you move on to the next slide. Now, rather than looking at the results in isolation, what I want to do is compare and contrast the FINOS survey with one that was published just a year ago. Was it a year ago? Oh, you lose track of the years at the moment. A little while back by Linux Foundation. It's the 2020 FOSS contributor survey. The key difference here is the FOSS contributor survey was cross-industry. Financial services was something like 8% of the overall industry mix, whereas FINOS is financial services specific. So by comparing and contrasting the two, we can highlight how financial services differs from other organizations. So if we look at the next slide, the first question I'm going to look at is the employers' policy on incorporating open source libraries. So this is the policy on consuming open source. So the blue bars are FINOS, the red are FOSS contributors. So blue is financial services, red is a more broad industry demographic. So when it comes to employers' policy on incorporating open source, a modest number declare that they have no clear policy within their organization. Marginally more within financial services state that. There's a reasonable number within financial services that are simply not sure. However, the next two is where we see the most significant difference. Within the wider community, it is generally seen that use of open source is encouraged, whereas within financial services, the use of open source is accepted. And there's a subtle difference between the two. Other organizations encourage, financial services tend to accept. So that's a key difference. Now, if we move on to the next slide, we can learn a little bit about the challenges that people within financial services experience. And this influences the difference between it being accepted and encouraged. So we asked them what their most common challenges are. And I'm not going to read them all. Let's just focus on the top few. So the first one is identifying and resolving security vulnerabilities. So security is the most significant concern within financial services. The next two are about making good decisions. One of them is about which components and which versions to use. The next one is about when to upgrade components and frameworks. So the top concern is security, and the next couple are decision-making. So if you move to the next slide, if we look at the key findings of the FOSS contributor survey, one of their key findings relates to security, the biggest concern within financial services. And what they state is more effort is required on security. In their findings, they found that all contributors reported spending very little time on responding to security issues. And also, they reported that they do not desire to increase this significantly. And when they engaged with the community and asked them more about it, they feel that the most beneficial contribution would be from external parties helping them with bug fixes, security, and so on. So on the one hand, we've got financial services who see the biggest obstacle being security and vulnerability. On the other hand, the people that maintain these projects don't actually want to do this work. There's a gap here. So the obvious, at least obvious to me, the obvious solution here is perhaps financial services should be the ones contributing to solving this specific problem. So if you move on to the next slide, let's see how viable this is. Can financial services companies lend a hand? So the next thing we looked at is we asked them to express the statement that is closest to their current employer's policy on contributing upstream. And again, comparing and contrasting between FINOS and the wider open source community. So blue is FINOS or financial services, red is the broader community. Here you can see a significant difference. Within financial services, very few are of the opinion that they should always contribute upstream, whereas in the broader community, a sizable number, 35%, work in companies where they have a policy of always contributing upstream. Now, I further segmented this data. There's enough data within the FINOS survey to segment it by size of company. And when I segmented it to companies with 30,000 or greater employees, this difference became even more significant. So we have a problem here. Financial services struggle to use open source because of security concerns. The open source community do not want to tackle that, and the financial services community struggle to actually make meaningful contributions themselves. So if we move on to the next slide, let's have a look at what's actually stopping them. So here we asked, what do you think limits your employer's open source investment or discourages contribution? So within financial services, the biggest limiting factor that people see is a fear of leaking IP, intellectual property. Next is legal or licensing concerns. And finally, the next in the top three is a lack of understanding the value proposition of open source in general. So these are the things that they feel are stopping them from contributing and helping out with these security issues. So if you move on to the next slide, I guess I'm going to be a little bit flippant here. I know there's a lot more detail behind each of these, but I do generally feel that these top three concerns are somewhat misplaced. So the first one is a fear of leaking IP. Now, the vast majority of open source I've consumed within financial services organizations is framework and infrastructure code, whether it's Kubernetes or Kafka or all these other things, or whether it's logging frameworks. The possibility of leaking IP into a project like that is, to my mind, almost infinitesimally small. I think that is very much a misplaced concern. The next one is legal or licensing concerns. Firstly, most large financial services organizations have a lot of legal might behind them. They should be very well placed to solve legal and licensing concerns. Secondly, the vast majority of open source projects are quite mature and use well understood licenses. The vast majority of them use things like Apache 2 or MIT licenses. So the final concern, perhaps the trickier one to debunk, is the lack of understanding of the value proposition. So my answer to that is, let's ask the survey respondents and see what they think. So if we move on to the next slide, one of the things that we asked is, why do you think your employer should invest in open source software and encourage contributions? And they responded, a significant number said to become a more attractive employer. A significant number also said to improve the quality of the open source software that they're already consuming, to help with employee career development and improve culture. Lots and lots of this is very much around the cultural benefits of open source. Interestingly, looking at the FOSS contributors survey, 65% of respondents said that their current employer's support for open source software influenced their decision in joining that organization. It makes a huge difference. So if you want to understand the value proposition of open source, just go and talk to the developers that are actually working within your organization. So Hilary, if you move on to the final slide. As I said, it's been a whistle-stop tour, but this is a brief story based on the data that I found within the FINOS survey. So the first is takeaway points. Consumption is acceptable rather than encouraged within financial services. Security concerns are the biggest obstacle. On the flip side, open source maintainers don't want to invest in fixing these security issues. Financial services organizations in general are somewhat reluctant to contribute to open source. They observe these security issues, but for various reasons, they're unable to roll up their sleeves and help out. This problem is even more acute at the larger end of the scale. The bigger the bank, the bigger the problem this becomes. They have concerns that limit open source contribution, IP, legal, lack of value proposition. And I personally think that a number of these are quite misplaced. Yes, there is something behind each of them, but I don't think they are immovable obstacles. And my sort of take-home message is we need to tackle these obstacles and bridge the gap. Otherwise, we're not going to be able to fix the problem that sits between the two. So that's my brief story based on the FINOS data. Thanks, Hilary.
Thank you. Claire, back to you, I think, for questions.
Yeah, great. Thank you both so much for that. We have got a couple of questions in. You do still have time to get your questions into the question box. And I will just say that I did include a link in the chat box to where people can access the full report. So first question for you, will you be repeating the study again in 2022 and how might it be different?
That's a good question. I know that FINOS as an organization definitely wants to repeat this. There are metrics, there are things that we are measuring within this survey that FINOS would like to see shift in a positive fashion. So yes, it will be repeated. What will change? I'm sure we will change some things. It's only been a month or so since we actually published. So I think everyone involved is taking a big sigh of relief because it was quite an undertaking. I'd turn that question back to yourself and the audience. If there's anything else that you would like to ask, if there's anything else you would like to see addressed, then we're certainly open to suggestions.
Great. Right. One more question before we move on. How can the industry overcome some of the barriers that limit open source contribution in this sector? Who wants to take that one?
I guess that's probably my one again. I mentioned it in the talk, and I'll reiterate it once again. Talk to the developers that sit within your own organization. Better understand how you are actually using open source within your organization, because the fears that you have are probably not a true reflection of how open source is being used. Yes, IP is a concern if you're working on something which is very specific to your business model. If you've got some, I don't know, quantitative analysis tool or some pricing engine, yeah, that might have some precious IP. However, that will likely be running on Linux. It might be running on Kafka. It might be not running on Kafka. It might be running on Kubernetes or Docker. It might be running a whole host of open source technology where there is no potential for IP leakage. So better understand how you're using it yourself, and then you will probably understand that your concerns are somewhat misplaced and you should become more permissive.
If I could add to Colin's terrific response to say that yes, and we have examples of other industries having those conversations with developers. And I'll draw back on my mentioning the Academy Software Foundation. A lot of the industry executives, the legal teams, did not understand the value proposition of open source. It was when they finally bridged the gap with their engineers, with their developers, and the developers were articulating, if we could only share knowledge, if we could only work on these tools together and share this IP, and we'll go and compete on other things. We'll compete on story. We'll compete on the way we use these technologies and film presentation. Once there was that bridge of understanding between different lines of business, then we have traction. And that's when we can help. But it really comes down to conversations and roundtable discussions, and perhaps even having those outside of an organization, bringing in regulatory bodies and helping shape their understanding of what really happens in these project environments.
Thank you both so much. I think that's a perfect point for us to stop. And I'm sure that people can reach out to you afterwards. And like I say, click on that link, and I'll include some more information with the link to the recording that we send to everybody tomorrow as well. So for now, thank you both so much. And next, I want to pass you over to Abby Mitchell. Abby is a quantum developer advocate at IBM, and she's going to be taking us through an introduction to open source quantum computing. So I'll let you share your screen, Abby, and over to you.
Hi. All right. So can you all kind of see the screen okay? Give me a shout if not.
Yeah, looks good.
Great. Yeah, well, hi everyone. My name is Abby. I work at IBM, and yeah, I'm going to give you a whistle-stop tour of quantum computing and open source quantum computing in particular. So just to kind of get started, I normally like to talk about a bit of a tangible example of where quantum computing has the potential to have an application in the real world. And I like to use the example of a road trip. Let's say I want to go on a holiday in the UK and I want to visit 14 different cities. And say I wanted to use a normal laptop computer, like my classical computer, to figure out all the different routes that I could take. With just 14 cities, that's about 3 billion different routes, which could probably take your normal computer maybe about a second to compute all those options. But as you start to add more and more stops to your road trip, more and more cities, your problem actually grows at an exponential rate. So by the time you are at 22 cities, and like you haven't even doubled the amount of cities at this point, but now you're in the realm of like 25 million trillion different routes, which would take your classical computer, I think the estimate is about 2,000 years, just to be able to calculate all of those options. So you can see the problem like this, like each small addition of complexity to the problem makes it exponentially more difficult to solve. And these are the kinds of problems where quantum computers have the potential to provide some kind of advantage. And you can think, okay, this is a trivial example about my summer holiday, but you can imagine this can scale up to problems relating to global supply chains, logistics, molecular simulations, financial modeling, all that kind of things. And quantum computing really represents a new paradigm of computation that utilizes the fundamental principles of quantum mechanics to perform these kinds of calculations where you get this exponential growth in complexity as you scale it up. Before I go any further, I should just say as a caveat that quantum computing there's a lot of hype around the technology. And it's not going to change your life overnight. We're not going to see all of our classical computers replaced with quantum computers anytime soon. But it's a really fast developing space. It's a really interesting area of research and development. And so it's just a really interesting topic to know about and learn more about, which is why I'm here talking to you about it today. I'm going to cover a few different areas, mostly where we are right now, how we've gotten to where we are, some key kind of definitions and terms you might hear floating around, like the news and different science articles you might read. Then I'm going to talk about where we're going, what the future of quantum computing hopefully looks like. And then this is an open source meetup. So of course, we're going to talk about open source and quantum open source. And then finally, I'll share some useful resources and we'll have time for questions. I'm not going to go into detail of quantum mechanics principles. I'm not going to talk in detail about how quantum computers actually work. The most that you'll probably need to know to get by with this talk is that classical computers work on bits, lots of strings of zeros and ones. So your laptop is a classical computer all made of bits. Whereas quantum computers run on quantum bits or qubits. And the fundamental difference is that qubits can encode a lot more data per qubit than classical bits on classical computers can. And that is where this kind of dramatic increase in computational power comes from. So where are we now? How have we gotten to where we are? So quantum computing, although it's quite a new, flashy topic, it's actually really been around, in different research circles for quite a while. And we can probably track quantum computing to really think about when it started. You have to think about the start of quantum mechanics as a discipline of physics, which really came about, started to become a big thing during the Solvay conference in 1927, which was basically the biggest party of the day for all of the biggest brain people like Einstein and Bohr and Marie Curie. Anyone who was anyone in physics in 1927 was at the Solvay conference debating the topic of quantum mechanics. And yeah, spoiler alert, it was a big deal. And it kind of survived through the rest of the 20th century as a legitimate physics concept. And then by 1980s, when we're starting to see more of an explosion in kind of general computing, a guy called Richard Feynman started to propose this idea of a quantum computer. And his main kind of line of reasoning was that if we want to start simulating the world around us effectively, nature is not classical, nature is quantum. So we can't hope to accurately simulate our world with classical computers. They're just not sophisticated enough. We need a quantum alternative. And then it wasn't until 1998 when this actually kind of became a reality. Up until then, everything had been purely theoretical. But in 1998, we got the first working quantum computer. It had 2 qubits. And this was a really exciting moment where we actually start to see that, this is a viable technology that we can start to push forward practically. And by 2016, IBM released the first quantum computer that's available via the cloud. Up until that point, you would have to, if you wanted to run an experiment on a quantum computer, you would have to physically go to a lab and run it. Whereas now, since 2016, you can access quantum hardware through the cloud, from the comfort of your own home. And since 2016, different industry players have been developing the hardware more and more, increasing the number of qubits. I've just got IBM's examples here because that's where I work. Most recently, in fact, just about a few weeks ago, we announced the first commercially available quantum computer that has more than 100 qubits. So that's really exciting considering where we were, 20 years ago with just two qubits. This is what they actually look like in real life. Actually, if I go back 2 slides, you can see this diagram here. This is what the inside of those big columns look like. This is where the qubits actually are kept. And they have to be kind of surrounded by all this other infrastructure because a qubit itself is essentially a subatomic particle. It's very, very, very small, very, very, very fragile, subject to a lot of influences from the environment. It's very sensitive to those changes. So you need a lot of infrastructure around it to kind of keep everything in place, which brings me on to the current limitations that we have with quantum computers in the hardware specifically. And that is, we talk a lot about increasing the number of qubits in your quantum computer as kind of a metric for like increasing its computational power. But what is also true is that the more qubits that you have in a system, the more difficult it is to keep those qubits working as they are supposed to work. So while it is true that by increasing the number of qubits, you can encode a lot more information, you can do a lot more powerful calculations, it also means that your qubits will just kind of not survive very long enough to necessarily do anything useful. A qubit, because it is so fragile, we say it can decohere. And the more qubits you have, the more noise there is in the system that can cause that decoherence. So this is temperature fluctuations, any environmental factor, like a light breeze. And like I said, they're very sensitive things, qubits. So they really, we need to think about the strength of quantum computers in more than just number of qubits. While it is important, obviously, because the number of qubits indicates how much information you can encode, you also need to think about the quality. You might, if you start reading into this topic more, you might hear terms like quantum volume going around a lot. And that's a metric for measuring like how good those qubits are that you have. And it takes into account things like the error rate, how interconnected they are and things like that. And then finally, also speed, because you can optimize your quantum computing infrastructure in such a way that even if your qubits don't last very long, you can do more operations on them in a shorter amount of time. And so that can also kind of increase the computational power of your machine. And another term that you've probably seen a lot in headlines and things is this idea of quantum advantage or quantum supremacy. This is when we say that a quantum computer has achieved quantum advantage, when that quantum computer can do something that no conventional computer could do in a reasonable amount of time or at all. So if it takes your classical computer 2,000 years to solve a problem, but it takes your quantum computer 10 seconds, that is a quantum advantage. And there is a lot of debate going around about, have we achieved quantum advantage? I think Google last year said that they had, but then IBM came back and said no, actually they kind of challenged it. And that's kind of the exciting space we're at the moment in terms of research in this field, is that the hardware is not in a good enough state yet that we can easily claim that quantum computers give us an advantage over classical computers. But we're exploring that space, and it's an ongoing area of research, and it's really I get very nerdy about it. I find it exciting to watch it unfold. So where do we hope to go with this technology? This is a newer photo of what IBM quantum computers are kind of being built. As you can see, it's a lot bigger, hopefully to hold a lot more qubits. And IBM specifically has a roadmap that they've published of where they hope to take the technology in the next few years. They have quite aggressive hardware goals, increasing doubling the amount of qubits pretty much every year, because then the more qubits that we have that are good, the more that we can start to use them in more practical situations. But what we're also seeing is that even though the hardware at the moment is maybe not at the level we need it to be to give us a quantum advantage, there's still a lot of work that's going into developing the software layer and the other layers of the stack to kind of make sure that there is software available so that by the time we are in a state where we can achieve a quantum advantage, those software tools are there and ready for developers to start using them. So some of the applications that are kind of particularly exciting or prominent that people are investing a lot of time and energy in, one is finance. In finance, there are kind of two spheres at the moment where we have quantum algorithms that we think will have a good chance of having an advantage in the near future. One is kind of optimization type problems. So portfolio optimization, portfolio diversification. You can use quantum variational algorithms to optimize those. Another area is estimation type problems, where things like option pricing, fixed income pricing, credit risk analysis, making predictions basically. And that would use a quantum amplitude estimation is the kind of the name of the algorithm that most that fits those types of applications most appropriately. I'll send you there are lots of links at the end where you can go and look into this in more detail. I'm really just giving a very high level overview of things at this stage. Another application area is chemistry. This one I find particularly exciting because this is a real area where classical computers are just really, really limited. Simulating a molecule, and obviously this has a lot of applications in developing drugs, fighting diseases. If we can simulate molecules and develop drugs quicker, this is a huge area. And currently classical computers just are very, very bad at simulating molecules basically, but quantum computers could stand to have a real advantage. They can handle those types of really, really big simulations with lots of atoms and orbitals and things like that. And the final one that I'm going to talk about in a bit of detail is machine learning. I know quantum machine learning just sounds like all the buzzwords thrown together, which it kind of is. It's just a really hot area of research that people are very excited about, obviously because there's a huge machine learning community. And yeah, so people are looking for ways to optimize machine learning techniques with quantum hardware, and there's a few different ways that this can be approached. If you think about, there's the data preparation side and the data processing side of machine learning. If you could there's potential to use quantum computers to help prepare the data, but then you could do classical, feed it to a classical machine learning model, or vice versa. You could have classical data preparation techniques, but then feed it to a quantum machine learning model. Or you could have, both your data preparation and your processing done in a quantum way. I like this example because it really shows how classical computation and quantum computation are not, completely adversarial competing technologies. I think we'll see a lot of collaboration where you use quantum technologies to augment classical methodologies that already exist. So they can work in tandem. And there are just, lots of other different applications. Basically, anytime you have a really big problem that you want to solve that a classical computer does not have the capacity to solve, that's a potential area that a quantum computer could be applied to. So logistics, simulations, material sciences, cybersecurity. Yeah, it's like a very big area that we still don't know yet where the best applications are going to emerge, which is why it's so exciting. Okay, and very quickly, I know I'm running out of time, but quantum open source. IBM has a software development kit that they use for quantum computing. It's called Qiskit, and Qiskit is all open source. So that means that if any of you are interested, you can get involved. You can help build software that can be run on quantum computers. We have a lot of repositories. I'm not going to go through all of them. I'm just going to give you a broad overview. We have 3 GitHub organizations where different stuff lives. We have Qiskit, Qiskit Community, and Qiskit Partners. Qiskit is kind of the main organization where you can find the core repository, as well as repositories that are kind of specific to different applications like machine learning or finance. It's all written in Python, but there are a couple of repositories that are also that are not Python. We have Qiskit Air, which is for simulations of quantum hardware, which helps us, develop the hardware itself if we can simulate it classically, and that's written in C++. And there's also the Qiskit.org, website itself is also open source. So even the web developers, the Vue framework fans out there, there's something for you to contribute to as well. Qiskit Community is more of the kind of community-focused initiatives. We have a kind of an online textbook where people can go and learn about quantum computing. So if you want to contribute to that, the repo is here. Translations as well. We really want to make the documentation as accessible as possible to different groups. So if you speak another language, please come and submit a translation. And there's also ways to kind of give us feedback and stay more involved with the open source kind of meetings and opportunities and things through there as well. Qiskit Partners is for stuff that's more kind of related to closer to the hardware. Depending on whatever kind of hardware backend you're using and you want to plug that into Qiskit, there is a provider repository that handles that, and they are available in the Qiskit Partners organization. Okay, finally, just some very quick resources for you to go and learn more about quantum computing, about Qiskit, get involved. The GitHub links are there. I'm just going to leave this up for like 5 seconds. So if you want to take a screenshot of this slide, please do. I think Claire's probably also going to share some of the links as well. You have like 3 more seconds and then I'm going to move on. Yeah. And finally, there is a Slack workspace that you can join to kind of get involved in the community more. There's lots of different channels there that you can kind of interact with other Qiskitters and the core maintainers. And then there's Twitter as well, if you just want to kind of keep up to date with what's happening. Yeah, that's pretty much it. And now I guess if there's any questions, I'm happy to take those. I guess I'll stop sharing my screen.
Thank you so much for that, Abby. That was absolutely fascinating, and personal thank you for increasing my knowledge of quantum computing by 100%.
Great.
We do have some questions that are coming for you, and I do have all the links for further information that you kindly gave me. So, like I said earlier, I'll include all of that in the email that I send to the whole community, along with the recording of today's meetup, and I'll do that tomorrow. So here are a couple of questions for you. First one, as a developer, I'm concerned about the differences in computational models in classical versus quantum computing. Is this something that's being looked at in making quantum computing accessible to more people?
Yeah, so I think there is, it depends at what layer of abstraction that you want to be working at. And I think there's, at the moment, most of the breakthroughs are coming from quantum researchers who are working a lot closer to the hardware. And that requires thinking about, it requires quite a lot of, I think, like quantum physics knowledge and expertise. And that's kind of where a lot of the work is happening right now. But I think there is definitely kind of in the roadmap, like this is where these kind of applications modules become are going to start becoming a lot more popular, is that like once we've developed, reliable models and algorithms, that by understanding stuff close to the hardware, they can kind of, those models and those algorithms can kind of just be stuck in a library, and then they can be used like a lot further up the stack. So I think you'll start to see in the next few years, probably, you start to be able to kind of like integrate quantum, like a quantum library in your normal software development workflow. I think kind of the same way that you would like classical machine learning now currently works. You might do like most of your programming in a normal way, and then you just like, you call some machine learning library to do like the specific part that you need. And I think we'll probably start to see a similar format with quantum computing as well.
Great, thank you. Next one. Are you aware of any open source projects of quantum computing in finance or the machine learning space?
Why, yes, there is Qiskit Finance and Qiskit Machine Learning. Please go and look at them. So there's obviously IBM has its own applications modules for each of those. There is also a few other ones out there. Penny Lane, I think, is another quite popular one for machine learning specifically. That's the one that springs to mind immediately.
Great, and I'm going to squeeze one more in for a very quick answer. I don't know whether you can answer this quickly, but it's what's the difference between quantum data and quantum processing?
Yeah, sure. So it's like the way that you like you can use again, I'm not like a machine learning expert. I'll just answer that quickly first. But like the way that you prepare the data, when you're doing machine learning kind of computations, you'd have to do a lot of like data preparation side of stuff normally, to like classifying things to feed into your neural network and stuff like that. So that's like what I mean by like the data preparation side. And then like the data processing is like the actual, like the neural network, the model that you feed your data into. I hope that. And like there are, again, I don't want to get into like the details of the quantum mechanics of it, but like you can add, like you can do it in a quantum way as opposed to a classical way. And yeah, definitely go and look it up with the resources that I posted later. You could do a whole hour-long talk on it.
That's perfect. Well, we'll have to get you back some other time for sure. Thank you so much for that. Thank you for joining us today. And I'm going to hand over to our next speaker now. We have Maxwell Shu. Maxwell is developer relations at Digital Asset, and he's going to talk us through how you create a tokenized asset in 20 minutes. So over to you, Max.
Hi, everyone. My name is Max, a developer advocate here at Digital Asset. And today I'm really happy and excited to be able to share with everyone exactly how you would go about creating a tokenized assets using DAML, which is an open source smart contract language. So, briefly, I'd like to give an intro of Digital Asset, the creators of DAML, and show you exactly just a bigger picture of who exactly are the people that are using DAML today in production, that have adopted smart contracts in their business, in their tech stack. And then finally, to be able to give you guys a concrete example of smart contracts and how it's being used. Every day we hear the buzzword smart contracts. We know they're using cryptocurrencies, but to, I guess, physically see these lines of codes would help you solidify kind of the mental model and understanding of how this all works and ties in together. So without further ado, let's get into it. These are the 4 points that I'll be going through today, right? Company introduction, the features of a tokenized asset. So it's more of a blueprint on what we expect when we talk about assets that are tokenized. And then finally, I'd also like to actually give you guys the correct mental model, especially when you're coding with DAML, and to see how we would want to, I guess, position the entire workflows for everything. And it's important to know that today's topic won't cover everything related to, the back end, the front end, and how you would build out a system that uses smart contracts, but rather just the core code, which is written in DAML. So we were founded in 2014 and currently in 6 offices. I'm based in Hong Kong, and we're working with 5 of the top 10 stock exchanges in the world, such as the Hong Kong Exchange, the Australia Stock Exchange. People that use us right now include tier 1 banks such as JP Morgan, BNP Paribas, and most recently announced, in fact, just I'd say about a month ago, maybe less than a month ago, Goldman Sachs has decided to use DAML to build out their tokenized asset platform. And also other technology companies such as IBM, Samsung, and VMware. So that gives you a context that smart contracts, they're not just tied into the permissionless blockchain crypto world, right? These are companies that have, for example, the Hong Kong Stock Exchange, Australia Stock Exchange. These are companies that have found a way, that have found value in adopting and using smart contracts in their tech stack, even though that they're clearly separated from the permissionless world, which is the wild west of blockchain, Bitcoin, and everything that we hear about today, Ethereum. So when we talk about tokenizing assets with DAML, there are a couple of, I would say, main features that we need to keep in mind. And these are being able to mint or produce the asset, being able to divide the asset, and being able to transfer the ownership of that asset. The companies that I mentioned use DAML today because, number one, it provides flexibility in terms of the underlying structure, as well as how straightforward it is to build out the tokenization ecosystem with DAML that include the features that I've mentioned just now. And I'll give you a rundown of the code in a bit, but basically tokenization is the process by the issuer creates a digital token, and that's put on a distributed ledger. So it doesn't really matter actually what blockchain at the end of the day that you decide to use. The most critical thing is how the smart contracts are written. And I say it provides flexibility, and that's because when you write with DAML, right, the developer, as the developer, you don't have to worry about which blockchain to use. Do you want to use Hyperledger Fabric? Do you want to use a centralized Postgres database? Do you want to use the Corda blockchain? You don't actually have to worry about that at the time of building your POC or your product. When you write with DAML, you can write that, and that it's an abstraction layer, which then you can actually deploy onto various distributed infrastructures. So that actually takes out a huge sunk cost when you're trying to develop and evaluate a system to build on. The second thing about DAML is that it's extremely clear. It's an explicit language, it's functional, and you'll see that in more detail later. So I won't try to verbalize all of that for you. And I also won't be going into, say, why tokenization. That's stuff that you can easily kind of go on to Google and search the benefits of it. But I'm more interested in talking about the technology, the underlying technology that the companies are using today. So on the left-hand side, like I mentioned,
sorry to interrupt, Max, but a few of the audience are just getting in touch to tell us that they're still just seeing your first slide. There we go. It's moved along there now. Perfect. Thank you.
Okay.
Back to you.
So did you guys even see the second slide or anything, or?
No, it was just stuck on your first slide.
It was just stuck on this first. Okay. Is it, what slide do you see now? This is tokenizing assets with DAML, that slide?
Features of tokenized IOU.
Okay, it is lagging a little bit. Hold on. Okay, back to features of tokenized IOU. You guys are on this one now, right?
Yeah.
Okay, perfect. So left-hand side, features of a tokenized IOU. The example that I'm going to be running through today with the DAML smart contracts is an example of an IOU. Or you can also think of it as just cash backed by, say, a government, say the US government. They would back up a dollar bill. So that is the asset that we will be going through today. And the mental models that you guys would need so let me actually just work out the entire flow for you guys, right? An example so you can follow along. Say Bob, right? We'll start out with Bob. Bob gets $100 from his bank and proceeds to give $50 to Alice, okay? And do you guys see the slide that has two blue boxes that says transfer of ownership and asset division? I just want to make sure that we're on the same slide.
No, not yet. We're still looking at Bob and Alice. There we go. Now we can.
Okay, that's better?
Yeah.
Okay, so let me rewind a little bit. Bob gets $100 and gives 50 to Alice. All right, in this natural workflow, this everyday process that we do, there are two things happening here. There is a transfer of ownership where the bank transfers ownership of $100 to Bob, then Bob splits that $100 into $50, he can have a $50 change, or he can give Alice $100 and Alice gives back Bob $50, then that becomes another transfer of ownership. But in this workflow, these are the two major things that are happening, okay? Now, in the real world, the bank can just give Bob $100. But in the world of DAML, there's the mental model that we need to pay attention to. It's called the propose and accept pattern, okay? What the bank essentially does is that the bank has to ask Bob, hey, Bob, would you like $100? And Bob can decide to accept or reject this $100. So the bank is proposing to Bob whether or not he wants $100. And this is because when you're writing smart contracts, everything is in code. So you need to be explicit, right? You're not allowed to obligate someone into a contract. If you think of this as an example of a gym membership, right? A gym cannot just obligate you to be part of the membership. And your obligation in that case would be to pay a monthly bill, right? You can't be put on that contract without your consent. Similar to a rental contract, the landlord can't just put your name on the contract and suddenly you have to pay the rent on a monthly basis without your consent. Therefore, when you're writing smart contracts, there is the propose and accept pattern. With every contract, both parties need to be in agreement. And that's what we talk about is the propose and accept pattern. So what does that look like physically on your screen when you're writing? On the left-hand side, you have the IOU template written in DAML. And let me see if I can zoom in here for you guys. Yep, that works. Right. Is my screen zooming in, or it's not zooming in?
No, it doesn't seem to be zooming in.
Okay, that's all right. I'll just briefly explain because I'll be sharing my IDE in a bit. But on the left-hand side, you can see that this is the IOU template. When we define a template, you can actually list, for example, the data fields. So in this case, on the left, we have the issuer, the owner, the currency, the amount. And you can think of these fields as columns in a database, and each template as a table, right? And in this case, we have also, you can see that on line 18, when you're writing the DAML code, it very clearly specifies the rights and obligations. So the controller of the IOU, what can this controller do? He or she can split it and can transfer it, right? So it says the owner of the IOU can do that. So for example, if I was the bank and I issued you an IOU, the bank would be considered an issuer. Now, in this code, it explicitly states that it is the owner who can do these things and not the issuer. So the bank can't transfer your IOU without your permission, only the owner of the IOU. And on the right-hand side, we have the IOU transfer templates. What that is just your propose and accept patterns, right? If we look at line, let's say, let's look at line 43 again, the IOU owner. So if I'm the owner of this IOU, I can actually decide to just cancel my transfer or reject the transfer. Now, all of these rights and obligations are clearly coded. And what differs from general purpose programming language, in this case, that would be Golang or JavaScript, is that in general purpose programming languages, you have to be very, very specific. The if-else statements become endless when you're dealing with privacy and authority. And with DAML, it becomes explicit. Who can do what? It's the owner, it's the bank, it's whoever can do what is clearly written. So I've gone through this already, but the blue boxes show you the portions of the DAML template code. As I said, you have your data model. The privacy and authority comes with the keywords such as the signatory and the observers. The signatories just basically mean who signed off on creating the contract. And then you have your rights and obligations, or basically the who can do what, which is defined by the controller keyword. And when you're writing this and the entire workflow, right, this is what actually should go on in your mind, right? When I create an IOU contract, on the left-hand side, this first blue box, that's what it would look like as the data field represented visually. The bank starts out with $100, right? And the bank can split or transfer. Now, the bank would then initiate a transfer to Bob, right? New owner is Bob, and that previous contract is now archived, right? It's archived. It's not deleted, but it's just archived because in DAML, all the data is immutable. You cannot just, delete it off the database. So the bank decides to propose $100 to Bob. Now, Bob can decide to accept it. Now, once it's accepted, and a new IOU contract is created with that amount, but this time with the new owner as Bob and no longer the owner as the bank. Now, with this new contract, Bob can decide to split or transfer, and he decides to split it. So once he splits it, it becomes two contracts now. Two contracts, but the quantity of the contract has changed, right? Now each of these contracts are worth $50. And Bob can decide to do what he wants with one of them, which is to transfer that to Alice. Now remember the propose and accept pattern. Bob cannot just obligate Alice to the $50. He needs to create another IOU transfer or a proposal. And then Alice can then accept it. And in that case, at the very end of the day, on the left-hand side would be the start, right? We started out with $100 in the bank. At the end, the ownership, if you can look at the owner column, which is the fourth column, Bob is now owning $50 of the contract, and Alice also has $50 of this IOU contract. So what we've done is that we have just created a workflow where you get $100 and you decide to split it. And that's just a very simple workflow that you can create with DAML. And let me see. All right, and I just wanted to let you guys know that you can go ahead and go onto bit.ly/try-DAML right now and just set it up on your computer. Download the SDK, play with it, start coding out your smart contracts. We have very thorough documentation. And once you're there, all you have to do is just install the dependencies. Once you're done with that, I'm not going to bore you with all the entire process, but you can then, hold on. Stuck a little bit. Can you guys let me know what screen you're seeing right now?
We're still looking at your bit.ly link.
Okay. Doesn't seem to want me to change to the next slide. Okay, there we go. What I want to let you guys know is that you can just go on Google and search the IOU Quick Start Tutorial DAML, and that will go into a lot more detail the steps that I've done to create the IOU flow that I had just done. And then once you have it downloaded, all you have to do is run daml new quick start template. Actually, what we can do is we can send the slides around later, and you guys can go through this as well, but this is also in the documentation. So let me just pause right there. And what I'm going to do is just open up the IDE real quick and show you the code as it's written. So I'm going to stop my sharing real quick and share my other screen. So can you see my IDE right now?
Yes.
All right, perfect. So once you've downloaded the IOU example, this is what you're going to see, right? On the left-hand side, you can see in our DAML directory, we have our IOU.daml templates. And these are white space sensitive, so you can see how I've written them. And the templates are your source of truth for every smart contract. It defines who can see what and what can happen in it, right? So like I said, issuer, owner, this is all the stuff that will be in your smart contract. This smart contract cannot be created without both the issuer and the owner's consent, okay? And the people that can control the things, right? Only the owner can split it. Only the owner can transfer it. If we go into main, what the DAML SDK allows you to do is that you can actually test your smart contracts locally, straight from the IDE before you even want to deploy it. And I'm just going to give you an example right here. On the left-hand side, I've opened up the table of what you would be able to see once you load the scripts and initialize them and start doing things with it. So on the left-hand side, we have our code. Let me enlarge that. And what I'm doing here is I'm creating an IOU, and I've assigned, the bank as the issuer and the owner, and I've defined my currency and the amount. What happens on the right-hand side is that you can see an IOU table. This is our initial state. Now, if I uncomment these one by one, which are actions here, in the second line, in line 27 and 28, what I'm doing here is I am going to transfer the $100 to Bob. Now, what you can see is on the right-hand side, I'm going to show my archived contracts. Now, this old IOU contract has now been archived, and a new one, and an IOU transfer has been created by the bank. Okay, so this is the active contract that we see, and the owner and the issuer are still the bank. What we need now is for Bob to accept this transfer proposal. And once Bob accepts it, you can see that this contract, this IOU transfer has now been archived. And in the IOU table, the second row, there's a new IOU contract with now the owner as Bob. So it went from the bank to Bob. So what did we want to do again? We wanted Bob to split his $100 into $250. So when I uncomment the rest of the script, we can see this line by line. Now Bob has two active contracts, both worth $50. And Bob now wants to transfer, so he makes a transfer proposal. And on the bottom right here, the owner right here for the transfer proposal is Bob, and the new owner is to be given to Alice. And finally, what happens now is that Alice can accept it. And at the end of the day, now we have two active contracts, Bob and Alice, both $50. So this is what I mean by creating a tokenized asset and a workflow. In this case, we've tokenized cash. We've given it the features of being able to split, merge, and transfer ownership. And with, I'd say the basis of DAML, multiple types of workflows can be used. The Hong Kong Stock Exchange is using it to actually lower settlement times. Goldman Sachs is doing something. They're creating a tokenized platform. The specific asset, not sure at the moment. But yeah, this will conclude my today's presentation. I can see that I am about 20 minutes, 19 minutes and 30 seconds. But I highly encourage everyone today to go ahead and go to bit.ly/trydaml, download the SDK. and give it a go. Let me stop my screen share.
That's great. Thank you so much, Max. And thank you for motoring through despite all of those technical difficulties. I know how frustrating that can be. We've got some questions already coming in for you. So let's dive straight into them. How does DAML compare with Solidity that can be used for similar use cases?
Yeah, that's a great question. So I'd say Solidity is basically a general purpose programming language, right? It's inspired by JavaScript. Now the key thing to think about with DAML is that it basically guarantees privacy, and it does it with the observer keyword. In my smart contract code, I can decide who gets to see what, and the transactions that go along with it, right? In a permissionless blockchain, all the transactions are visible, right? So you cannot actually define the privacy settings, I'd say, and the authority, the who can do what. The who can do what is you can probably do that in Solidity or any general purpose programming language, but I'd love to just copy and paste an example, but it just becomes very tedious when you're trying to define, I guess, the authority, the authorization rules, in any type of general purpose programming language. So those are the main differences in terms of the clarity and the privacy, the explicitness when you're writing the code. And like they say, more lines of code means more lines of error. I hope that gives a general answer.
Absolutely, yeah, thank you for that. Right, next question. Has DAML ever been used for regulation tech? Would it be appropriate to capture rules and regulations?
Yeah, excellent question. And that is what DAML was born for, basically. Has it been used explicitly in reg tech? Like, for example, I guess technology company like law firms and whatnot? I don't think so, but for example, when we're working with these exchanges, these are heavily regulated entities. The code is written to capture the rules and the regulations, the contracts, what the parties can do, what the exchanges can do, what the banks can do. So I would say yes. It might not be in that industry vertical, reg tech, right? But the actual capturing of the regulations deemed by the government, the rules set out to guide these entities in how they act, it's exactly what DAML is used for.
Great stuff. Right, next question. What happens if Bob doesn't accept the IOU transfer? Does the existing one get unarchived, should I say, or does another one get made for the bank, the same as the old one?
Yeah, great question. Yeah, basically, right? So if Bob rejects the IOU transfer, the transfer contract gets archived, and the original IOU contract is it wouldn't be the original, but a new IOU contract with Bob's or with the original sender's name is created again. So there's no change in ownership. That's what happens.
Great stuff. And I've got one more question here, and that is, can I write blockchain applications if I only know Java?
Can you write blockchain applications if you only know Java? I would assume so, but then again, it depends, right? Permissionless blockchain, every network has their own language, right? Ethereum has Solidity, Solana, and what, I guess I forget what it's called. They have their own language. Avalanche, they all have their own language. Now, the thing with DAML, it's another new language, but if you're going from Java, strongly typed general purpose language to DAML, which is something I would say much more straightforward to learn, it's going to be easy, super easy. Yeah.
Well, that's a great way to end this, I think. And we have run slightly over, so apologies to everybody, but thank you for those who've stuck with us. And for everybody else, we will be sending out the recording tomorrow, plus all the extra links for further reading, as I mentioned earlier. So all that leaves me to say is thank you so much to all of the speakers for tonight's meetup. And thank you to all of you for joining us as well. I hope you found that useful and interesting. And I look forward to seeing more of you face to face when possible in 2022. So that's all from me for now, and bye for now.